We've been working on some problems that require the chain rule, right? We're doing derivatives involving or with functions involving compositions, and this is number 41 from a recent assignment. It's kind of a doozy, more so in the way it looks than in the actual execution of the problem. For this one, I'm actually going to write out the U substitution that we follow through on when we do the chain rule. It's going to make things a little easier to deal with. So the idea here is this nasty quotient function was plugged into a power function. And so I'm going to call this entire fraction here U. And I'm going to work on U separately. So U is sine theta over 1 plus cosine theta. And then that means that my function f, and we'll call this f of u, and u is actually u of theta, f is then just u squared. And so f prime is just 2u, okay? And once I figure out what u prime is, I'm going to multiply those two derivatives together. That's the whole idea behind the chain rule. So to do u prime, I need to run through the quotient rule. And typically we'll use u's and v's to write that thing out, but because I've already used the letter u, I'm going to kind of avoid that, and I'm just going to write out the derivative right on one line as though I had already done the u's and the v's. So the u prime from my u substitution for the chain rule is going to look something like this. It's going to be v u prime. So that means v, which is 1 plus cosine theta, times u prime, the derivative of sine theta, which is also cosine theta, minus u v prime. So u is sine theta, and the derivative of the denominator is going to be 0 plus negative cosine theta. So that's just negative sine theta, I should say. And I'm going to crash into my green there a little bit. So that's v u prime minus u v prime over v squared, which would be 1 plus cosine theta quantity squared. And I just need to clean this thing up a little bit, and then I'll be able to multiply my two derivatives together. So I'm going to distribute the cosine. Let's see what happens. I get cosine theta, cosine theta plus cosine squared theta minus negative sine squared theta, so that's plus sine squared theta over 1 plus cosine theta quantity squared. Ooh, I like where this is going. Take a look at this. Cosine squared theta plus sine squared theta, that's just equal to 1. That's our Pythagorean identity. So in the numerator, I have 1 plus cosine theta, and in the denominator, I have 1 plus cosine theta squared. So I'm going to cancel those and reduce. And so my u prime is actually just 1 over 1 plus cosine theta. I canceled one of these factors, one of the factors in the square, with this cosine theta plus 1. This guy turned into a 1. Okay, so my u prime is 1 over 1 plus cosine theta. So now I just need to multiply these two things together, and I'm going to do it in yellow. I'm going to multiply 2u times 1 over 1 plus cosine theta. And that means f prime of theta, my original function was f of theta. F prime of theta is going to be 2 times u, which is sine theta over 1 plus cosine theta, times 1 over 1 plus cosine theta. So that's going to be 2 sine theta over 1 plus cosine theta quantity squared. I multiply this by 2. That's my u. So u times 2 times my u prime. And that is the derivative, all squeezed on one slide. It could be worse, But 2 sine theta over the quantity 1 plus cosine theta squared. 1 plus cosine theta quantity squared is usually how we say that. So this thing right here, that's the derivative. Hopefully this helped you understand how to identify the composition, and in this case we had to do the quotient rule to get the derivative of the composition. Then when you're done, you just multiply f prime and u prime and you end up with your actual derivative. If you have questions on this one, feel free to ask when you see me again. Take care.